Everybody, welcome back to Thoughtfully Critical. I'm Chris. It's good to have you here. Today I'm going to be talking about systems design, or really, well, for a long time I've been in charge of building things, typically large type systems, programmatic type systems, things that involve a lot of people. And a common question is, how do you do this? Or how do you advance your career to the point where you are the person doing this design work, architecture work, leading the solutioning of such things? So I thought I would take a stab at that in this episode and try to talk about my approach, tell you some of my secrets, if you will, to systems design. And that's it. We're going to go through that and have a little bit of fun. And I prepared some slides, as I usually do, for us to go through. I think the major caveat to cover first is that systems design, or really building anything, requires a process. It's an iterative process that you need to go through. So one, I want to recognize that there's always a lot of pressure when you're in charge of designing things. Typically, time is a major pressure source. Budget, there's not infinite money. The staff that you have, pressure's a thing. And hopefully there's this internal need to see what you have in your mind, or really what the team has in their collective minds, coalesce into something that comes to life. That should be the driving force behind the desire to design things. You want to make things. Early in your career, I think it's very common to want to rush this process to get to the end very quickly. And that's a lot of what I'm going to be talking about today, is that's the trap that's going to create the janky and unmaintainable systems that you and I have both had to experience, right? We've been consumers of these systems, and that instead of trying to rush to perfection or the final stage or the final boss, whatever you want to call it, using a deliberate, phased approach is going to yield better, quicker, cheaper, higher quality results for you and your team. Something I've written about in the past and continuously try to leverage, no matter if it's building systems for large corporations, for startups, or for video games, is a 3-phase build approach. Phase 1, we're going to prototype. We're really worried about learning what the system can do and increasing our own domain of knowledge. In the second phase, we're going to start scaling and kind of pressure testing what we've built to learn how our system reacts to more real-world scenarios. And then finally, we're going to polish what we build into something that we're willing to hand over to others, because one of the key pieces to being a builder, especially when you're doing systems design, is handing it off to others, because you've got to go build other things, right? That's kind of the gig. If you're building it and then going to maintain it forever, well, that isn't typically all that satisfying, and it's not typically the reality of things. You're typically going to have to keep building more and more systems, and that's going to keep forcing you to grow your skills and challenge you to do bigger and more interesting things. Let's talk about phase 1, the prototyping phase. Got the little questioning guy here with the magnifying glass, because this is really where you're asking the basic question, does this crazy thing or idea even work? So in the first phase, when you're looking to build, you shouldn't even really be thinking about what the final version is necessarily going to look like, or not worrying about that. First phase, you're just playing the piano, you're making some jazz, you're exploring, you're learning, you're recognizing that there's a lot of things you don't know yet, and it's important to go learn those things. And so be messy. It's fine. No one's using the system. It's in a sandbox. It's in your head. It's in a lucid chart, whatever. The main goal when you start to design a system should be, can it actually work? What happens when I connect all these bits and bobs together that I know I'm going to need, or I'm required to use, or I'm constrained away from using? It should be about, does the functionality exist, or do I need to build some of these components? It's about the logic string of getting where you begin the process to where you end the process. And it's really just finding out all the unknown unknowns. And there's going to be a lot of those typically. Maybe they come in the form of assumptions. Maybe they come in a form of poor documentation. but you're going to have to actually build some version of the solution in order to learn a whole lot of stuff. So this is the learning area, and I put on here, it's when you're building this raw, unpolished, but glorious mess. It's going to be ugly, it's going to be inefficient, it's going to be held together with duct tape and baling wire, but that's okay. You just want to prove, like, does the idea work? Now, I want to show a photo here of a game that I'm enjoying. It's a game called Foundry, and I'm a self-admitted lover of colony games and colony simulations and building games. I love factory games. I've written about Oxygen Not Included and Satisfactory and a few others, but Foundry is kind of my latest obsession, if you will. And this is an example of my phase 1 prototype construction of this factory that makes things. The things that it makes doesn't really matter. And it's horribly ugly. There's conveyor belts with materials being shipped all over the place. I didn't even try to make it look pretty. I kind of gave it this multi-level architecture. I built a lot of different components and learned what components feed into additional components and what finished goods require those components. But I didn't worry about making it look pretty or be efficient or scale. I just wanted to learn and experience what the game had to offer. And a lot of folks would call this spaghetti. If you played factory games before, this is the spaghetti, because all of those conveyor belts and systems are just kind of messily pushed together. But it forms a delicious meal, right? You're still going to get to eat the spaghetti. You're going to get to enjoy learning the system, and it's going to teach you a ton. And that's how I went from not knowing how that game worked to Mr. Thumbs Up Chef Guy here, letting me know that I at least made a single plate of pasta given a whole lot of learning. Now, why this is crucial is really the hands-on experience part. It's very difficult to have opinions when you don't have experience. That experience should form a very fundamental set of building blocks that you're going to need when you design something. Nothing is going to work as advertised. No documentation is perfect. There's always a little bit of a lag between reality and the last version of documentation or guidance or manuals or whatever, right? So I just feel like when you go to build a prototype, when you put together that spaghetti, you're going to uncover the complexity that you maybe didn't even know was there. Or if you did know it was there, now you're going to find the nuances of that system. So again, we're just trying to find a viable solution to the problem that works, but you wouldn't ever want to put this into production. And that's important. Once we're done with that first phase, there's a lot of learnings, there's a lot of lessons that you've experienced, and you're going to have more opinions. And that's when we get to phase 2, really about engineering for scale, for growth, for applying pressure, and for saying, okay, we know this is a viable idea. It can work, but how do we make it big? How do we make it the size that we need it to be? Whether that's the type of services that you're going to use, whether or not it's the scale of the users that you want to work with. The key piece here is we're going to take that original plate of spaghetti, we're going to push it aside, and that's going to feel tough in a lot of cases. Like, you made that spaghetti, it's your baby. You want people to enjoy it, but no, put it aside, either get rid of it or just shelve it or put it, somewhere in a corner, put a gold star on it, excellent effort, and start fresh. This is where I'm going to highlight a common error that I see from people that want to design by taking the prototype and optimizing it. Don't do that. Don't do that. And that's why I say in that first phase of prototyping, don't worry about making it perfect and pretty and polished and whatever else you want to use as an adjective for that type of design. Don't try to optimize it. Recognize the fact that whatever you built for yourself or your very small group of people is not actually going to be what the system is going to look like in the future. And I have an example here. If you're building for 10 people and then you start trying to build for 10 million, the designs will look different. Be okay with that. In the second phase, I've listed out a few things that you should be thinking through. 1, performance. actually put some load on this new system, or think about how you're going to put load on it. Where do we bottleneck? Whereas before, we didn't care about scaling any of the different components. Now we may need to actually do the math. How many components do we need? How many downstream systems are going to rely on those components? What architectural patterns do we want to use? I'm not going to assume that. Now we have some opinions. We put our hand on it. Oh, we actually need some cache here. We need some services that are kind of microservices or mini services there. We need a message bus or a queue or whatever it is. Like, we understand now the type of sauce that we want to put when we make our spaghetti. Where are we going to put our data? How do we access that data? I'm not going to beleaguer the point, but think of it as now we're trying to apply some pressure to the system. And whereas before in the prototype arena, pressure would cause it to collapse, now we're looking to resist that pressure and actually thrive when that pressure exists. I think it's important to call out as well that re-architecting either the whole thing or significant portions of the thing or whatever is normal. I wouldn't advise just making it slightly better. I would actually look into refactoring and re-architecting the way that you've designed it to meet that scale and rigorously test performance. Because now we need to understand kind of, again, those bottlenecks, but in a system, it's going to perform differently based on the pressures that you apply to it. And in some cases, you may find that the services that you've picked or the technologies and tools that you've selected worked great for 10 people, but with 10 million, they're either too difficult to scale, they don't survive the pressure, they don't meet the performance requirements, and that's where that re-architecting, I think, really becomes salient. So it might still lack some polish when you're done with this second phase, but it should work, and it should work when you make it big. So as an example here, going back to Foundry, after I made that really ugly spaghetti-filled factory, I went for my second phase and said, okay, how can I start to make this more modular, more scalable? And I realized after that point, I could make these platforms and I can have very well-defined inputs on my left side. And then in the middle, I've got these different factories that are modular and creating whatever it is that I need. And those all go to the right side as outputs. You can see all of the things are kind of lined up and organized. It's not perfect. There's areas where the polish isn't there, but I started working through the scale of the system. How can I produce enough widgets to make sure the downstream systems aren't starved for resources? Or the other way around, how do I make sure that those resources are being supplied at a rate where everything is functioning at the scale that I wanted it to function, knowing that this wasn't the complete phase yet? And so going back to the pasta example, we're not making a plate of pasta with our meat spatulas anymore. We're building a factory that builds pasta. Maybe a small batch factory at the moment because we're learning how to automate these components and make them performant, etc. This is an important and fun part of the process because now you're starting to see what it's really going to look like when you get done. And the crucial thing about this is that this is going to form the kernel of your core architecture, right? We're really solving that core architecture. We know the tools and the services and the components that we put together work and work under load, under pressure. We're not trying to, in my example here, bolt on an extra cabin to our airplane and say good enough, right? We're not taking that prototype and just trying to make it and force it into something that scales. We've started with a system that's designed for that. The biggest benefit to this approach is that not only are you going to save yourself a lot of time, because trying to take a prototype and make that act as a production system is going to fail most of the time. It's going to require a lot more time, money, and energy than if you just do it this way in the first place. But you're going to assuage a lot of concerns that would be only found in production if you skip this, right? We don't want those emergencies to be the learning moments. We want this second phase of scaling and growing to be where we find those issues, right? So that we're just paging our team or the developer team or whatever it is, something smaller, something internal. Friends of the project are able to find these things. And it's a much safer place to learn versus having to do it right in front of the users that are expecting a flawless, polished system. Speaking of polished systems, that's phase 3. That's where we're going into that polish, that delivery of what you've built. Think of it as, can I build something that I hand over to others and they don't need me to understand and consume it? It's really kind of the vibe here. So question 3, phase 3, are you ready for the world? If you have a functioning, scalable core architecture, you can really start thinking about, how do I polish the rough edges? How do I abstract away the complexity? And how do I make it so that users have all of the tools and the hints and the quality of life components necessary to consume your design? I also highlight that this is a great time to have already identified and then start paying down the technical debt. Or if you haven't identified it, find it. Start paying down that technical debt. You're not experimenting anymore. You're ready to make this thing final and scalable and super uncrushable when it goes down in the depths of the ocean. I also think it's really important to think about the joy that people using and maintaining the system will have. There's definitely a feeling that you get when you're working with frictionful, toil-heavy systems that even if they scale and they perform well, they can feel janky from a kind of experience perspective. If there's a joy to using the system, if it feels good, it reacts well, it's smooth, it's simple, it does what you expect it to do every time, those are great indicators that you are in phase 3. Because if it sucks to use and maintain the system, people are not really going to want to use it very much. So thinking about mass consumption in the tech world, it could be, wow, we're putting together really awesome, richly defined documentation for our APIs, for our abstraction layers. Our user experience is top-notch. It's really intuitive and easy to use. Your team is not having to deal with that user experience. It's just inherent in the system. That's important because you don't want your team having to support this thing at that level all the time, right? You're moving off of that. You have other things you and your team need to deal with. Maintainability is a big one. If it's robust, if it's a lot of testing, a lot of automation, again, that means you're not having to kind of ad hoc look at the system whenever it changes or suffers an issue. Security should be top-notch. Like up to this point, you've probably been using sandboxes and dev environments, and now you're going into production, and you want to make sure that all your security concerns have been obviated, that they're part of the system, they're just inherent in it. Should have been thinking about that all the way, but this is where we really finalize that component and say, yeah, we've tested it, we've tried to look for vulnerabilities to penetrate the system, etc. The final thing is operational excellence. You're not ready for the world until this item's complete, or so complete enough that it's not a concern. The system must be monitorable, deployable, and manageable, because that's the only way you're going to be able to scale to meet the demands of the system. And again, get your team off of this system from a day-to-day building and maintenance perspective. You really want to be able to hand it over to others to consume, because that's the only way you scale and your team scales. You don't want to babysit this thing forever. Going back to Foundry, this is the more recent version of my factory. It looks a lot different because it's designed for massive scale. I've got huge conveyor belt ribbons going through the world with a number of factories built modularly, pulling off of the ribbon to grab materials and finished goods and then put new ones back onto the ribbons. We've got entire lines of production that are smelting goods and producing goods and putting them into the system or pulling them out. And so it looks a lot different than that first version of spaghetti because that's been designed to be that way. And I wouldn't have been able to build something like this if I hadn't experienced the prototype version and the grow version, because all of those experiences taught me where things should go and how they connect and let me make mistakes and experience different products that I'm going to have to build. And so similarly, in our pasta example, this is where you got that big automated factory. There's no people running around here doing anything. The system is kind of on its own. We can add as many pasta machines as we want to this thing. We can make bucatini noodles or spaghetti noodles or angel hair pasta. Whatever it is can be constructed because we put all that thought into the system up front. Now, why this is crucial, this is the final version. This is the one not only end users will use, but probably your developers or other consumers internally are going to be using day to day. And I put in here that it doesn't matter how powerful or scalable your system is, it's going to be useless if people don't understand it, they can't integrate with it, or it can't be maintained. And so those should be the things like, do I feel like everyone understands what this is and how to use it, how to integrate with it, and how to maintain it? If not, you're not done with this third phase. I also want to call out that abstraction is key here. In my original version of this, I called it prototype, scale, abstract, but then I thought that the abstraction might turn some people off. So I think abstraction is a major component of the third phase of building things. It hides a lot of the complexity that people don't need to deal with. There's a lot of people that don't need to know that complexity. They just need to know that it's handled, because the cognitive load to consume the system should be as close to zero as possible. People shouldn't have to know how the pasta is made. They should just request a plate and the chef magic happens in our spaghetti factory, and then boom, they get the spaghetti, right? That's kind of the vibe there. Another topic to talk about are some perils through this process. The number one peril that I see people go through is wanting to either skip ahead or they get stuck on one of the phases. The main reason that I hear people wanting to skip ahead is because they see all this stuff. They see the phase 1, put it aside, phase 2, learn a bunch of stuff and scale it, kind of put that aside too, and then polish it and you get a phase 3. Wow, Chris, I've had to build 3 things of the thing. Why don't I just build one thing and get it right the first time? That's faster, right? Well, if you watched Office Space, there was a jump to conclusions, Matt, that this guy was going to quit his job and go make a whole bunch of money off because, you know, he made some money off of this system. It didn't work out too well from him. The problem with trying to skip ahead is really kind of twofold. One, you don't know what you don't know, and trying to build abstractions on top of this poor level of understanding will fail. Period. It's not going to work. Even if it looks like it will work, it's not going to, because you just don't have enough telemetry and understanding on what you're trying to build to skip ahead. Now, if you've done this 100,000 times, sure, you can probably skip ahead. You can make some assumptions. But even then, I would advise going through the process. The other concern, the other peril of skipping ahead and not going through this 3-phase approach is that scalability is a function of the process. Understanding where those bottlenecks are, understanding how the pressure that you put on a system will cause that system to react is something that you have to go through. It is a process. Figuring that out later by skipping the process and doing it in production is the most painful way to figure it out. It's really going to turn you off to this whole being a systems design type person. It's way more expensive. It's not only just expensive from a dollar's perspective, but to your reputation, to your company's reputation. It's expensive in terms of probably what's going to happen is the features and functionality and the user experience is going to suffer. And so it's expensive in terms of what you're actually going to get to deliver. You're going to have to deliver less or take longer to do it. There's always going to be a trade-off. And so I just think that if janky design issues and scalability issues are something you've experienced, then you know what it looks like on the other end to skip the 3-phase approach. Don't skip it yourself. The other peril that I'll talk about is getting stuck, because there are definitely teams that love to live in the prototype phase way too long. They overthink it. They spend a lot of time in there trying to make it look perfect and beautiful and right angles and shiny glass mirrors and things like that. And no, phase 1 is just there as a teaching tool. It's there as your Lego bricks scattered on the floor for you to put it together to look like something without stepping on the bricks, because that hurts. If you try to live in that phase too long, you're going to be forced to go to production with a prototype, and you're going to build this Frankenstein that is going to suck in production. It's impossible to scale something reliably when you do this. So just think of phase 1 as the ugly version of what you're going to build to get the education for yourself and for your team so that you can build better things. Don't get stuck here. In summary, this is the flow: prototype, scale, polish. If you go through these processes, you're going to learn a ton. You're going to learn it very quickly. You're going to be able to get through these phases very quickly. And more importantly, you're not going to have to loop back as much as you would if you skipped them. If you go straight to the polish phase from a prototype, you're often going to have to kind of go back, start over, deal with issues, work 70-hour weeks, work weekends, have bags under your eyes, have burn marks over yourself from all the outages and issues that you're dealing with. For quality of life for yourself, for your own sanity, this process has, in my experience, been quintessential to my success. Again, going through a phased approach isn't about adding unnecessary work. It's not like, hey, let's make this more convoluted than we need to. It's really just admitting that there are challenges to building systems. They are complex. There are stages of the life cycle of system that you need to go through. There are pressures that you need to apply, and that the life cycle will benefit by going through a phased approach. If you do this, I promise you, you will learn faster than you would if you skip them. You will build more robust architectures. In some cases, my designs have lasted 10 to 15 years, and I come back and I'm like, I am amazed that this thing is still running. And folks go, well, it just works, and we know how to use it. And we just kind of keep it up to date. And ultimately, it's going to let you deliver systems, because going back to our first part of this podcast, I said that, you really want to see your ideas come to life. If you go through a process like this, you have a much, much better chance of seeing those systems come to life that will be elegant and maintainable. And I think those are the hallmarks of very strong architects and designers. When I see elegant and maintainable systems and I get to work with them, I want to use those systems. I want to tell my friends about those systems. I want to meet the people that made it and go, how did you do this? Lastly, I'll say that this takes discipline. You're going to feel pressure from your team to take what you've initially built in the prototype phase and ship it. And having the guts and the intestinal fortitude to not do that, to say, we're going to throw away these prototypes, we're going to use them as learning vehicles, will pay off in much better designs. So I'm obviously curious. Have you used a system like this? Do you use a process? Is it 3-phase? Is it some other type of process? Do you think this is all craziness and you just go YOLO, prototype to production, love it, it's someone else's problem? Let me know in the comments. I'm curious. And I think that this is a community of sharing. And so even if it's yeah, this worked great, or no, this didn't work very well, both are very valid and valuable pieces of information to share. With that, I appreciate you joining me. As always, been lovely to have you here. Let's talk again soon. Peace and love.